Hello everyone. In this video I wanted to share a little bit about my point of view as a piping engineer looking through a game. So this is Control, a game with a lot of industrial parts with piping, and this would be a very nice place to show off a little bit about actual piping design and compare that to how the game has done that. So let's start off at the coolant pumps. Okay, so we are here. Let's go ahead and check out the coolant pumps. Okay, so this is a pump in the game. It's very strange because it has 3 pipes here. I don't know what they're doing. I don't even know what the engine part of it is. And then you have... It's just a bunch of pipes, I guess. The first thing you'll see is there's a flange here, and there's another flange here, and there's another flange here. It's just a lot of extra flanges, which are not really needed. They add a lot of cost normally, because you have to make every connection like this. Flanges are used to connect piping in between, but not at every piece and at every pipe. But yeah, flanges look cool, so I guess that's where they went with it. I'm guessing this is like a very futuristic pump. This is pretty much what a normal pump outlet would look like. But looking at those larger pipes, I don't think this has anything to do with the pumps. Maybe this is a different line. So yeah, this is so far off a normal pump that I don't even know what it should look like. So I guess the most logical thing would be that... actually no, I don't actually... Okay, so the pump inlet actually goes right through the pump itself. It clips through. And then you have these bearings here that hold it up on one side, but the other side it's fixed to the ground. Yeah, it doesn't work anywhere. So here you have some pipes going through the floor. A lot of flange connections actually. The pipe also goes through the wall. You can also see this branch here and then this branch here. They are very close to each other. So if you would have like a standard pipe piece that you would fit into there, this is actually shorter than a standard pipe piece. So this would have to be fabricated specifically for this part, which is very expensive. So normally you would have this move a little bit to the left, and then you can use standardized parts and weld them together. And here you have pipes supported by concrete. This actually does happen, piping support by concrete. Normally though, you have steel supports because those allow you a little bit more flexibility for supporting the piping. With a pipe that is as large as this, you also don't really need this support here. I guess it's because of this part. The piping that is, the larger the piping gets, the less supporting it needs. And this one is definitely not needed because it's also supported here. So you have like 2 supports very close to each other. And here as well, the support very close. Normally you would make this a support under the elbow because that takes, well, no, this is actually not a bad way to do this because the pump inlet usually is very weak, so you can't really put a lot of force on it. I would maybe put the support a little bit to the right, but especially if you have different temperatures, making sure you don't break the connection to the pump is actually very tricky. So we have another pump here which is exactly the same, except you cannot actually get around this, so doing maintenance on this pump would be impossible. The layout here does not make any sense. Normally you would not have the pumps like lined up next to each other. Maybe make a little bit better use of space. You would put your pumps in a way that you can actually get like forklifts and stuff up to it. But here you have like these stairs, you cannot get a forklift off these stairs. So you have some pipes here. They are supported, but this support doesn't really actually do anything. As you can see, there's a gap between the support and the pipe. And then you have, these are pressure gauges with 2 connections to the pipe. you would only need one connection to the pipe. So maybe the other one is a support. The one is a support, yeah. That's actually pretty normal to have a support there. I don't know what the temperature is, but depending on the temperature you would want to have something to make sure there's a little valve here and the gauge doesn't get too hot, so you don't burn your fingers on it. And then here you have some pipes. This is like completely, yeah, just to look good. I think there is a support here, but the support is just under the flange. I think it's actually clipping through it. Can I actuate this? Oh no, I just took. So normally when you take off the handle, steam is not gonna come out. The steam is not coming through this. This is just like an actuator, and then the steam will only be inside of this. This is also not a steam pipe, because a steam pipe would first of all be protected so you don't burn your hands on it, and also to not lose too much heat energy from steam. The second thing is that a steam pipe going down here and then going to the left here, it would also need to have a steam trap, something to drain the water coming out of the line. There's also a flange here, but it's very close. This is also not a standard T-piece. Having like a loop here is actually, it does happen more often. So the reason you have a loop here is then because this whole pipe heats up, and when it heats up, it expands, and when it would expand, it would just break like the connection to this wall here. So if you don't want the expansion, the thermal expansion of the pipe to break everything, you would need to put a loop here. The loop is a little bit short, and the distance on the top is also short, so it's a very stiff loop. It's a larger pipe, so you would have a loop, need to have a loop that is like something like this, a bit larger. And then I would also not put a support at the loop. Well, maybe I would put a support. Yeah, if this is actually like steam or something like that, then you would want to. If you put a support here, you would have to put like a spring support on it, because else this pipe is gonna expand up, and when it expands up, it will lift off the support, so the whole support does not do anything. There are certain type of supports that have a spring in them, so the spring will just move along with the pipe and keep it supported. But normally for a pipe like this, you would want to have like an horizontal loop, and then you can put a support under that loop. And I guess this is the same. This is also kind of a weird thing. You have just a beam here, but nothing of a support. It's also clipping to the flange, and it's going through the floor here. Normally you wouldn't have pipes going to like the main entryway through the floor. Yeah, let's continue. This is the main power plant. So here you have, I think it's ducting for air or for hot gases, but there is no support at all here. So this, in reality, this would actually just move left to right. It wouldn't stay in place, because there's nothing holding it back. The larger the pipe gets, the stiffer it gets, but the ducting like this is pretty large, but it's also very thin because it doesn't have to hold a lot of pressure, so it would be pretty weak. And then here you have a very large pipe that's connected to concrete, because there is no other flange here. Concrete is not a good flange material, so this is more of a structural thing than anything else, because it doesn't do anything, because there's no pipe under this. And normally you won't want, if you're attaching a bolt here, you would want to have access to the other side to put a bolt on, which you don't have. This is a round pipe that is then connected to a square duct. That does happen, but the only way that would happen is if it's also very low pressure. So something like flue gases, like hot gases from a combustion process, it would happen like this. But this would still need stiffeners, something to keep this square. It would kind of bend in the middle and then go up and down, and then it would keep moving when there's air flowing through until it breaks off. And then you have this very nonsensical pipe that goes through the platforms even. It goes completely through the platforms. I mean, this is something that gets drawn up, and then once it gets under here, this is where the actual connection had to be. So this is like a manufacturing fault. It was actually supposed to go lower, but maybe someone lowered like this whole platform in the 3D modeling. In reality, you would just get a couple of very angry mechanics because it doesn't fit like this. There are some supports here, which are pretty okay. These are hanging supports, but the pipe is also not aligned with the supports at all. It is aligned here. You would also normally never use this kind of connection. You would usually just go straight up and then connect up to there. So you just have one special connection part instead of having like a very weird here bend here and then very weird bend here. In the other piping we saw a lot of flanges, while here I don't see any flanges. So I'm guessing they just use these connecting clamps, but there's nothing that actually clamps it shut. Yeah. Let's just continue. So this pipe here is the same issue as the other one. There's like no support at all. So this would break off, most probably. Like the other one. And normally, well, there's like a very nice slab here that they could have just supported this pipe from. So I don't understand why they didn't do that. Yeah, I guess that's it for this control area.
NSC, Northmore Sarcophagus Container. The two previous directors both lost control while dealing with paranatural forces. I don't want to make that a rule.
Let's check out the control room. Okay, so this is cooling water. It also has a lot of flanges, especially here. There's also no bolts on the other side. This would leak. And these are water pipes, and water pipes are very heavy, so this is definitely something you need to support, and it just floats slightly above the concrete slab. And it goes into the reactor here. And then these pipes, I don't know what these pipes are doing. Let's check out ventilation. So these kind of supports are used more often, but these kind of supports only work when the pipe is hanging off of the support. So this is a pipe on the side of the support, and the support would only be good if it's on the roof. So this would actually not work at all. And then this clamp here is this is normal support for hanging stuff from the roof, but there's nothing connected to it. So yeah, that does not work at all. This support might hold on. It's also, the support is like right into the bend. So if you look at this ventilation ducting, this is pretty much how you would normally hang up a ventilation duct. You can see there's like an angle beam here, and it's suspended from the roof. Here you just have pipes going right through the wall, which is impossible to do in real life. There's also always like a little bit of a gap, or sometimes because of fire resistance ratings you need to seal it tight. But especially if you want to do any kind of maintenance on it, you want to make like a square opening where they can go through, but something you can still access afterwards. And then these pipes here are, or these ducts I think, are not supported up in here. And they just all go like through the wall, and without any support it's more like decorative. I'm guessing these are ventilation units. There's air coming out of this side. So then this would be a pump, a fan or something like that. and then these pipe connections will be heating water or cooling water. But there's like this looks like a pump, but then there's a pipe on it. So yeah, this is like a terminal box for an electric motor. But an electric motor does not need a water connection. Also, this flange here is a lot thinner than this flange here. And this valve does not have another flange on it. These are like different pressure classes. This is also not a multiple flanges. This is a single flange. I'd say the biggest issue here is that this pipe is coming from there, and it would actually put a lot of load on this ventilation unit. They didn't really use real components, at least put like a real thing there and then connect it incorrectly. But it looks cool, so at least it has that going for it. Maybe this is like a pump unit for the whole ventilation system, which is inside of here. I can see like ducting inside of this whole case, and then you have air outlets. I wonder where the inlets are then. And those are still the same everywhere. And then you have these things. I have no idea what it is. It does have like air coming out of it, but what does it do with the air? I don't know. So, to give this game a rating, I'm gonna go for 5 out of 10. I haven't looked closely at other games yet, so I can't really say if it's better or worse than other games. I think it's probably on the better end, because at least they put in pipes, at least they put some supports in. Not everything is floating in the air. There are different kinds of components. There's pumps, even though the pumps are nonsensical. The components at least are all there, but the components have been mashed together, and that's kind of the problems. It's mashed together. The supports are very strange, number of flange connections, and also just having pipes going through the walls and going everywhere is not really how it normally would work. It does happen sometimes, but most of the times pipes are put together and they are sequestered to under the floor area, and there's some thought going into where they would go. Thanks for watching. If you have any ideas on what games I can look at in the future, please put it down in the comments, and have a nice day.